and I think we're going to do level. So we'll start with pressure. First thing to know about pressure is that there's already lots of it all around us. Just in the atmosphere. We live in a place with lots of pressure. There's at least one atmosphere of pressure around us all the time. If I get a tube, a glass, like, where's my little hands gone? Right, like this glass tube here, and I stick it, it's a very long glass tube, it's about 12 meters long, and I stick it in a very big deep bath of water, and then I pull it out. What happens is the water comes out with it, but it only comes out to a certain level, about 10 meters, and then something forms at the top here. There's a hole at the top here. It's a vacuum. When they first did this experiment in, I think the 16th century, people got very, very upset because, for a start, they couldn't understand why the water didn't fall out of the tube. And secondly, they didn't like the fact that there was something at the top here. In fact, they didn't like the fact that there was nothing at the top there. Because what's at the top there is a vacuum. And they didn't like the idea of vacuum because the church thinking at the time was, if there's a vacuum, there's a place where there isn't a God. And if there isn't a God, well, the world's going to fall apart. So a lot of people got very upset by this experiment. But what this experiment is showing is, when you pull a tube out from the water like this, you get 10 meters of water. What's happening is that there's pressure. Oh, that's pointing the wrong way, isn't it? Oh, typical. What's happening is that atmospheric pressure is pushing downwards on the water level. The water in the tube is also pushing downwards, but it's being balanced by the atmospheric pressure. When the weight of the water in the tube, when the water in the tube weighs exactly the same amount as all of the atmosphere above it, so when the water in the tube balances, the pressure downwards from the water balances the pressure downwards from the atmosphere, then the water stops rising. I'm not sure if I've explained that very well. Basically, what this means is, the upshot of this is, you can suck water 10 meters upwards, and no more. If you try and suck more than 10 meters, you won't suck anything. You just suck vacuum. You can blow water as far as you like, but you can only suck for 10 meters. So that's a rule. You can suck for 10 meters, but you can blow as much as you like. I'm just going to have to stop and think about that for a minute. Of course, this became a big problem when they started cutting mines, coal mines and things underground, because they needed to get the water out of those mines. So for that, considering you can only suck 10 meters but you can blow as far as you want, where do you need to put the pump on a mine? That was like a question.
At the bottom, mate, or halfway. Use one at the bottom, use one halfway up.
That is exactly right. You have to put the pump at the bottom. Now, as electricians, what this also means is, if we have, let me draw this. If we have a bore in the ground and it's full of water, then we have to put the pump at the bottom. You have to use a submersible pump. Now, as electricians, you know the very last place you want to put an electric motor is 300 meters underwater, because electric motor, water don't normally mix too well. But because you can only suck 10 meters but you can blow as far as you want, if you have a bore or you need to drain a mine site, it needs to be at the bottom. Right, now when we're measuring pressure, we're always measuring against something else. So whenever we measure pressure, we compare it to something else. If we have a closed off pipe, such as this pipe here is closed off, and here at the top we have vacuum. If you're comparing pressure to a vacuum, and we'll say for the sake of argument so the vacuum is absolute zero, then we call it absolute pressure. So when we compare to absolute zero, we say it's absolute pressure. On the other hand, if the pipe is open, such as this one, then on one side we have the signal, and on the other side we have atmosphere. Let me just draw that in. Atmosphere. Now, when we're comparing to atmosphere, we call it gauge pressure. So you would have a gauge pressure gauge. If you're comparing one signal with another signal, we call it differential pressure, because you're comparing the difference between the two. If the truth be told, all of the time we're always measuring differential pressure. It's just a question of what is it at the other end. In absolute pressure we've got vacuum. Gauge pressure gauges we've got atmosphere. Differential pressure gauge we've got another side, something else we're measuring the pressure against. Normally we have gauge pressure gauges. Now what I'll do is I'll bung in a screen here and show you why we normally use gauge pressure gauges. If I have a tank full of water and I have a pressure gauge at the bottom, if this pressure gauge were measuring, if it was a absolute pressure gauge, the pressure it gives me here, right, no, that's wrong. The pressure that I get at this gauge would be the water pressure plus the atmospheric pressure above the water. So, as you probably are aware, atmospheric pressure changes according to whether it's stormy or whether it's cold. So sometimes atmospheric pressure might be hanging around at, say 1010 hectopascals, and that's high pressure. Or we might get a low pressure of 990, oops, that's a 9 there, hectopascals. So atmospheric pressure changes. What that would mean would be that this gauge would read incorrectly depending on whether it was stormy outside or whether it was cold outside. So to get round that problem, what we do instead is we don't have an absolute pressure gauge there. We have a gauge pressure gauge there. Gauge pressure. And with a gauge pressure, atmospheric pressure is beating down on the top of the tank, but atmospheric pressure is also beating down on the outside of the gauge. So it cancels out. What that means is the only pressure that this gauge tells me is the pressure caused by the water level in this tank. So we normally use gauge pressure gauges because we're not actually interested in what the atmospheric pressure is doing. In fact, we take the atmospheric pressure to be a constant of 101.3 kPa. I mean, I know atmospheric pressure changes all over the place, but just for the sake of making our life easier, we take 1 atmosphere to be 101.3 kPa. And so we say the difference between an absolute pressure gauge and a gauge pressure gauge is 101.3 kPa. Okay. Right, different types of gauges then. if the pressure gauge is zeroed according to earth pressure, it's called a gauge pressure gauge. If it's zeroed according to vacuum of space, by the time we brought it down to earth, it would be reading 1 atmosphere, which we take to be 101.3 kPa. So we call it an absolute pressure gauge because its reference is absolute zero. Oh, that went a bit far, didn't it? How did that happen? Now, when we're talking about gauge pressure gauges, we can sometimes get suction. We can sometimes get vacuum. So we need a way of expressing vacuum. We've got a couple of ways of doing this. Sort of place that this occurs is if I've got a pump, there's my pump, and it's got an inlet and an outlet. At the inlet part of the pump, I should have suction. And at the outlet part of the pump, I should have positive pressure. So I say I've got pressure there. Now, if I need a way of expressing this suction, a couple of ways I can do it. I can say, okay, I've got 25 kPa of suction pressure. Or I could say I've got minus 25 kPa of pressure, which is 25 kPa less than atmosphere. Or I could also express it in terms of absolute pressure. So that if this is minus 25 kPa just there, then I would say, well, absolute atmosphere is 101.3 kPa. I've got minus 25 less than that. So in fact, with respect to vacuum, I've got 75.3 kPa here. So I'd say I've got 75.3 kPa absolute. And just here, if I had a pressure here, say I had plus 25 kPa, I'd have 126.3 kPa absolute. So I can express vacuum pressure as a negative value, or say explicitly write down this is suction or vacuum, or I can express it in absolute terms. It's important to do this so that we know that there's a difference between vacuum and pressure. Right.